Hi class. This lesson today will be on section 10.1 and 10.2. We are beginning circles today. Now, a lot of the information you may already be familiar with, hopefully a lot, okay? So I wanted to show you the vocab for section 10.1. If you're writing down notes, you want to pause here, and these are the vocab words for 10.1. And for 10.2, here's the vocab words. Okay, so if you're taking notes, pause the video here, write it down. Leave yourself some space to write down extra things. Things you will need for this lesson. You want to go grab a notebook or notebook paper and a writing utensil. You're going to need a calculator. If you don't have one, you can always use Desmos.com. Some of you brought your student journal home, which is for the honors class. That's the geometry book that you guys kept in my classroom in the cabinet. So if you brought your journal home, you want to have that with you. Or you can follow along in your textbook. Well, some of it, not everything. Okay? If you don't have either, I have copies of the journal pages that I'm going to go over. Let me show you what it looks like. So this is section 10.2. This will be on Google Classroom. We will begin with the vocab on page 285. And then section 10.1, we skip all of this and we start with vocab on page 280. Okay? Alrighty. So let's roll. So our learning goals for this lesson for 10.1 is to identify special segments and lines in a circle. So, a circle basically is a set of all points in the plane. Okay, I'm not going to read that to you. I'm just going to tell you in my words. So, all the points in the plane, that means you're on a flat surface. Okay, it's not 3D, it's flat. Equidistant, that word means equal distance or same distance. So every point on this circle is the same distance from the center of the circle. Okay? Anytime you name a circle, you name it by the center of the circle. So this circle is called circle P. Notice the symbol for circle and P. So we name this circle circle P. Okay. So you have lines and segments in the circle. You need to know that a radius of a circle is a segment that goes from the center of the circle to the edge. So let me show you right here. So for radius, so just that much is a radius. Okay. Also, see that red segment there? That's a radius. And from here to here, that is also a radius. Okay. Let me skip to diameter. So no, I shouldn't do that. A chord. A chord is a segment whose endpoints are on the circle. So if both ends of the segment touch the circle, that would be a chord. So let me erase this. So from here all the way to here, see how both ends touch the circle? That is a chord. Also, from here to here, see this green segment here where both ends touch the circle? That is a chord. Okay? Diameter is also a chord, but the chord has to go through the center of the circle. It basically cuts the circle in half. Okay? So diameter, that purple segment there. You also should notice that if you take the diameter is made up of two radius. Well, actually, the plural for radius is radii. Okay, radiuses, that doesn't sound right. So, anywho, two radii together gives you one diameter. So let me write that in for you because that's a good thing to take note of. So, diameter. Oh snap! I'm gonna put D for diameter. Diameter equals two radiuses. Okay, 2R. So if you know the radius of a circle, all you need to do is double it and that'll give you the diameter. Or vice versa, if you know the diameter, split it in half, that gives you the radius. So Sorry, erase that. So radius equals half of the diameter. Okay, let's roll. Secant. So that's a line that intersects a circle in 2 points. Remember, intersect means cross. So back up here to our diagram. Let me erase this stuff. So a secant, oh, I'm sorry, I should be down here. So see this green line right there? That's called a secant. It only touches the circle in 2 spots. Bam, bam. So that's a secant. The tangent is a line that only touches the circle at 1 point. So see that blue line there? That's a tangent line. And the point where the tangent line touches the circle is called the point of tangency. So point B is our point of tangency. All right, so we just went over the vocab. So now let's do some exercises. So in the student journal, this is on page 282. Name 2 radii. In other words, 2 segments that's the radius of a segment. Again, you should pause the video and try to find it before I reveal the answers. So pause the video and think of the answers to all of these questions. Write it down and then play the video to see if you got them right. And if not, you want to correct it and listen to my explanations. So segments, now let me just go ahead and reveal my answers here. So segment AD is a radius. Now normally in class, when we write a segment, we always put the segment symbol on top, right? But unfortunately, since we're typing our answers in, we don't have the segment signs. You feel me? So just put the 2 letters. Remember, anytime you name a segment, you must give me 2 letters. Okay, on the assessment. And if I ask you for a segment and you give me 1 letter, for real, that crap is wrong. You already know, so stop playing. So segment AD is a radius, segment AB is a radius, and segment AF is a radius because all of those go from the center of the circle to the circle. A chord has to touch the circle, well, has to have 2 endpoints that are on the circle. Segment DF is a chord because both ends are touching the circle. Pow, pow. Also, segment EC is a circle. Both ends touch the circle. Now, segment ED. Some of you might be like, wait a minute, Miss Speight. ED looks like a line, not a segment. Right. But remember, a segment is a piece of a line. So if I'm only looking at the piece of the line from E to D, that portion is a segment. So that segment would be a chord. Okay. A diameter. Remember the diameter, you're looking for a chord that goes through the center of the circle. So you should just come up with segment DF. That is the only diameter in this picture. A secant, that's a line that crosses the circle in 2 points. So this whole line, that sure is ugly. You know what I'm trying to say. That line is a secant line. So line ED is a secant. That is the only line that goes all the way through the circle. Okay, DF is a segment. It doesn't keep going. If it kept going, I would have said DF is also a secant. And there's only one tangent line in this picture, and that's line BG. Now, I want to note that in your book, they forgot to add another point on the line, so I added it for you because you know you cannot name a line with 1 letter. People don't even try it. So this is line BG, and it touches a circle at 1 point. The point where it touches the circle is your point of tangency. So that's point B is our point of tangency. And to name the circle, you just name the circle by whatever the center of the circle is. The center of the circle was point A, so we call this circle A. Okay? How we doing? Got any questions? Please write them or rather send them to me on Google Classroom, and I will definitely answer. Let's move on. Section 10.2. In this section, we are finding arc measures of a circle. We're not really identifying congruent arcs. Let me cross that out. We're not doing that. Okay? All right. So, a central angle. Notice the word central sounds a lot like center. That's because a central angle is an angle whose vertex, is the center of the circle. Let me go back to my highlighter. Highlight that. Vertex is the center of the circle. It's going to be a lot of angles in the circle. But if the angle has the vertex at the center of the circle, it is called a central angle. Let me scroll down a little bit. So this angle right here, bam, bam, that's a central angle because the vertex is at the center of the circle. So let me show you an angle that is not a central angle. Let's say you had an angle that did one of these numbers. Look at this. See that angle I just drew? See how the vertex is not in the middle of the circle? It's not at the center. That's not a central angle. That's another kind of angle, which we'll talk about later in this chapter. Or you can have some weird angles. Oopsie, what am I doing? Okay. You can have an angle do one of these numbers. Now, again, the vertex is in this circle, but it's not the center of the circle. So this is not a central angle. Not. Okay? Sad face. Don't get that. The vertex got to be in the middle of the circle, the center, in order to be a central angle. Okay. Any central angle that's less than 180 degrees is called, I'm sorry, rewind. Yada, yada, yada. Okay, an arc. So an arc of a circle, basically, see this little red line? An arc is basically a piece of the circle. I'm gonna write that down. What's an arc, Miss Speight? It's a piece of the circle. Piece of the circle. Okay, so it kind of looks like a little curvy thing, right? Because circles are not made out of straight lines, they are curves. So an arc of the circle is a piece of the circle. Now you have your minor arc and your major arc. Notice the word minor is small. When you hear the word major, you should think big. So now let's talk math. If it's a minor arc, it is less than 180 degrees. Okay? Let me write that. Minor is less than 180. But if it's a major arc, major is going to be more than 180. Okay? So this blue arc right here, that little slice of the circle is a minor arc. You name a minor arc with you name a minor arc with 2 letters. I'm going to type that for you. 2 letters for minor arc. Make it small, pow, bam. Okay? So you need 2 letters for a minor arc. Major arc is more than 180. See the blue portion of the circle? That's more than 180 degrees. Okay, so that's a major arc. You always want to name a major arc with 3 letters. I'll type that in for you. 3 letters for major arc. Major arc. Man, put that in there for you. Okay. Now, you might say, how am I supposed to know that's more than 180 or less than 180? That's a great question. Because a semicircle is 180. Semi means half. Okay? So a semicircle is half the circle. Semicircle equals half the circle. I probably should have typed this before I started, but well, you know how we roll. Semicircle is half the circle. And again, how would you recognize half of a circle? If you see a diameter of a circle, that means a segment that goes through the center of the circle. It's a chord. Okay, anytime you see a diameter, it's cutting the circle in half. So see all this right here? Let me use my little highlighter. Pow, pow. All of this is a semicircle. And then down here, all of that is a semicircle. See that? So that's 180, 180. Now, if it's less than a half a circle, it's a minor arc. And if it's more than a half circle, it's a major arc. Major arcs, you got to name it with 3 letters. Minor arcs, you got to name it with 2 letters. Measure of a minor arc. So this part is easy breezy. By the way, anytime you see M, and that's the little arc symbol, so that means measure of arc AB. Okay? The minor arc is the same as whatever the central angle is. Now, let me be a little more specific here. Here's my central angle. Angle ACB is my central angle. It's 50 degrees. You can see that in the diagram. Now, I'm going to look at my angle, and I'm looking inside of the mouth of the angle. It's like the angle is eating part of the circle. So the angle is eating this much of the circle. You feel me? So that is your minor arc, and it's going to be the same as whatever the angle measure is. So since the angle is 50 degrees, then the arc inside of that angle's mouth is also 50 degrees. Okay? So that's how you find a minor arc. Now, for a major arc, those are your arcs more than 180. You need to remember that a full circle is 360 degrees. So if you knew the minor arc, if you just subtract 360 from your minor arc, you get your major arc. So right here, the rest of the circle is your major arc. It's going to be 360 minus 50 degrees, which is 310. So all of this right here, that is your major arc, and that's going to be 310 degrees. 310. Because we did this right here. We did 360 minus 50. That gave us 310 degrees. Okay? Two arcs of the same circle. Yeah. They're adjacent because they're next to each other. Who cares? We don't need to know that. Arc addition. Now, you might find this to be common sense. Okay? So if I have two arcs next to each other, if I put these two arcs together, so look at the red arc and the blue arc. Together, if I put them together, I get all of this that I just highlighted in yellow. So you might be asked to find a major arc, and you might have to put some arcs together in order to find it. That's what arc addition postulate is all about. Okay, so we're not reading all this. Just know, hey, this arc is divided into parts. Remember how I tell you part plus part equal whole? Just add that crap. All right. So I put these numbers in. It's not in your book, but put them in. So let's say arc AB is 120, and let's say arc BC is 100. And I ask you to find major arc ABC. Well, you're just going to need to do your adding. So arc ABC, the measure of arc ABC, we need to add 120 plus 100. That's going to give you 220. Okay? So that would be all of that. So we're just doing some adding and subtracting in this part. Okay? It's going to be all good. Okay. Theorem 10.3, we skipping now. We don't need that. We don't need that either. We're not doing that. So let's do some practice. Now, I'm going to do these exercises. Again, I recommend you pause the video here, see if you can do them without me, and then play the video to check over your answers. And when you have questions, again, post them on Google Classroom. So, it says identify each arc as a major arc, minor arc, or semicircle. Why I keep doing that? Bam. And then we're going to find the measure of each arc. So before we begin, I like to look at the directions and notice right here is some important information. They're telling us that segment AC is perpendicular to BE. That symbol is perpendicular. Do you remember what that means? Perpendicular lines make right angles. So it's basically telling us that AC and BE is making right angles. So the symbol for right angle is a square. I'm going to draw a little square thingy right here. That's the right angle. How much is the right angle? 90. Let's put 90 right there. Now, my little square symbol, that's ugly. Let's try that again. Bam, bam. Well, that's going to be good enough. Now, remember, because this angle is 90, that means this arc right here is also 90 because this is a central angle and it's the same measure as the arc. You know what? I'm gonna keep going because I'm a more of a visual person, and some of you are too. So I'm basically gonna fill in all of these gaps in my circle before I even answer these questions. And I recommend you do that also. What else do I notice in this circle? We talked about special segments. Look at segment AC from A to C. What kind of segment is that? Segment AC is a diameter. Okay. What do diameters do to a circle? It cuts it in half. How much is half of a circle? 180. So from arc A, B, C, all of that is your half circle or semicircle. So all of this is 180. Well, if this slice is 90, then from B to C, in order to make 180, that slice needs to be 90 also. See what I'm doing? I'm filling in my slices. Next, I have another central angle. Do you see it? Angle DEC is a central angle. Angle DEC is 40 degrees. Look inside the mouth. That little slice of the circle DC is also 40 degrees. I'm writing that down. 40. How? Okay. That leaves me with the rest of the circle. Let me change colors. All of this. That will be the rest of the circle. So I like to look at my circle in halves. Again, segment AC is our diameter. So from ADC, ADC is a semicircle, which is 180. So this little purple arc, that's going to be the semicircle subtracting this little slice right here, subtracting 40. So let me change colors. So that slice is 40. I'm going to do 180 minus 40. I get 140 for this slice right here. So now I'm ready to do my exercises. Okay. So number one, arc AB. That is less than 180. So arc AB is a minor arc, and the measure of it is 90. Number two, arc ABC, that is a semicircle. Semicircle is 180 all the time. Arc ABD, from A to B, all the way to D. I'm going to add going all the way around the circle, starting at A, around till I get to D. So I'm going to add 90, 90, and 40. Let me write that for you. You're adding 90 plus 90 plus 40. So number three, you should get, when you add that up, 220. And also, this is a major arc because it's more than 180. Number four, arc BC is a minor arc. And we already found that it would be 90. Let me change colors just because I want to. Arc BAC. Again, dead giveaway. If it's three letters, it's a major arc, flat out. Okay? So arc BAC. Again, some people ask me, Miss Speight, how am I supposed to know which way to go around the circle? So the first two letters is the shortest distance. So from B to A, you don't go B all the way to A and then no, don't do that. You don't go B, skip all this to A. Don't do that. Okay, shortest distance from B to A to C. So I'm starting here. I'm going to add all these little arcs. So let me write down that this is a major arc. I want red. I said I want red. This is a major arc. And I'm going to add 90. That's the blue. And then this purple we said is 140. And then this little slice right here, that's 40. So altogether, I get 270. Okay. Number six, arc DAB. Another common mistake students make is they think they can cut through the middle of the circle. No, if it's an arc, you're going around the circle. You never go through the middle of the circle. So arc DAB, we know is a major arc. Let me move that. And from D to A is 140. And then from A to B is 90. And when I add it up, I get 230. Number 7, arc AD. That's my purple arc. You know that is a minor arc. And we already found how much it is 140. And number 8, arc CD. We know that's a minor arc. And we already found how much it equal, which is 40. So the important thing to remember, people, the full circle is 360. Half the circle is 180. Other than that, we just adding and subtracting. That's all. Okay, number 9. Tell whether arc ABC is congruent to ADC. Think about it. Pause here. Arc ABC is a semicircle. Arc ADC is also a semicircle. They both are 180 degrees. This is definitely yes, they are congruent. So I'm going to put yes because they're both 180. Or if you said they're both semicircles, that'll work. Okay. Number 10. See if you can do this one without me. Pause here. You're asked to find the measure of arc DE. Go ahead and pause. Here's arc DE. Okay? So what I'm going to do first is recognize where my diameter is. See that? From C to E is a diameter. That means all of this, all of this is a semicircle, which is 180. So I know, go back here, I know that since this is a central angle and it's 30, that means this slice right here is also 30. And then I have another central angle right here, 55. That means this slice over here is 55. So in order to find the rest of the slice, I need to subtract 180. I'm going to subtract the 30 and the 55. Okay, so for that slice, I got 95. That's what this is, 95. Now, why did I do that? My fault. I'm wasting y'all time because does that even matter? Hecky no. I'm messing up, y'all. Let me move this. I see another diameter in the circle. Where, Miss Speight? Right here. Check it out. That's a diameter. Again, diameter split a circle in half. So I got another semicircle. I'm gonna move this green line right here. Can I rotate it? Yes. Pow. Look at that. All of that is a semicircle. One more thing I see. Wait, I don't even want to do that. I want to look at this semicircle down here. Yeah, that's what I want. All of that is a semicircle. There we go. Come on. Do that. All of this is a semicircle. This slice right here is 55. So how would I find that slice? Well, we know a semicircle is 180. Let's just do 180 minus 55. We always want the easiest way. So my fault, I was about to take you all around the world. 180 minus 55. That's going to give you 125. How? That's how much this arc is right here. This slice is 125. 1, 2, oh, I'm on blue. 1, 2, 5. Okay? All right, last problem. Find the value of x and then arc AB. So first we got to solve for x. Then we got to find arc AB. Bam. Now, if I look at the diagram, again, pause the video and see if you can find it before I do. Do not get got. There are no semicircles in this picture because we don't have any diameters. Okay? We do not have one segment that goes all the way through the middle of the circle and whose ends are on both who touches the circles on both ends. Like there's no chord that passes through the center. So there will be no subtracting from 180 in this problem. However, what do we know about all circles, the full circle? A full circle equals 360. And we have all our slices. Look, that slice is 5x. And this slice is 40. And then this slice is 70. And this slice is 75 plus 2x. So guess what? I'm about to add all these slices, set it equal to 360 to solve for x. So I'm going to start typing. Okay. I'm going to add 5x, 40, 70, and 75 plus 2x. You do not need those parentheses. Together, it's supposed to total 360. Okay, now you got to have your algebra on point. First thing, combine your like terms. So the ones with the x's in it, they go together. Let me draw my little line here. The equal sign shows you where one side of the equation is. So all the like terms on the same side of the equation, I can combine. So 5x and 2x, that's going to give me 7x. And I have more like terms. I got 40, 70, and 75. Those are all like terms. Add them, and together you get 185. And that's going to be equal to 360. Now, here's my variable guy. I'm trying to get him by himself. That means this crap got to go. So it says plus 185. I need to subtract 185 on both sides. Minus 185. Whatever I do to one side, I do it to the other. When I subtract 185 on both sides, I get 7x equals... Hey, would it help if I did the math, huh? Let me see if my mental math is working. That's 0. That's going to be 16 minus 8 is 8. 185. Is that right? Nope. 175. Hey, I'm tripping. Man, let me just use my calci right quick. Where does most at? How? Where is it? Okay, here we go. My bad, y'all. You know how I roll. Now, what was it again? 360 minus what? Minus 185. No wonder I'm so slow. I wrote 180. Why y'all ain't tell me? 185. Okay. So 360 minus 185. 175. I knew that. My mental math be off, y'all. 175. Okay, 7x equals 175. So now I have to divide each side by whatever you see in front of the x. So let's divide by 7. Whatever you do to one side, do it to the other. Once you divide, you're going to get x equals 25. Okay? Now that I know x is 25, it says find the measure of AB. Remember, AB is this yellow slice. So AB is 5x. I have to plug in 25. So I'm doing 5 times 25. And my answer is 125. That's arc AB, 125. So AB, the arc, is 125. Okay? So to summarize, you need to know a full circle is 360. But if you have half of a circle, because there's a diameter split it in half, then it's easier to just deal with half a circle and subtract from 180. Questions, please ask me on Google Classroom, and I will be assigning you big ideas probably, and like, I don't know, something. You'll see. I'll post on Google Classroom. First bell work tomorrow. Bye, guys. Have a good one.